I've mentioned this before in talking about data visualization, but there's oftentimes a trade-off in terms of how we think about and present our data in terms of being viewer-centric versus data-centric. And data-centric really emphasizes the idea that this is a nifty way to present the data versus viewer-centric, which is this is an intuitive way for the viewer to understand that data. And that might not necessarily overlap with the cool things that we can do with our data. And so we have to kind of be on guard against the temptation to do new and flashy things that our audience might not be familiar with and might not be able to process as easily. And so as we're starting a new conversation about data visualization and patterns, I really want to begin with just a cautionary note that hammers home this principle that we need to think about clarity as we're thinking about complexity. And so as we're thinking about complexity, there's, I think, a useful way to think about this in terms of we're adding in additional dimensions to what we're trying to present. And so we talked about tables and how with tables you can easily sort of pick out conditional frequencies or conditional patterns looking just at the row for men. Well, complexity in data visualization allows us to do that as well. We can add in additional categories or sort of subgroups that we're able to study, but we also have to think about complexity in terms of things that don't fit into nice, neat categories, more continuous dimensions. And continuous data can be more difficult to present and to present clearly just because there's more information. And so we could think about that both in terms of we're adding more dimensions that we're looking at, but also the things that we're looking at end up being more complex. And again, data visualization is really useful because it allows us, or it gives us tools to be able to try to communicate some of that complexity and some of that messiness in a way that people can look at and quickly pick out patterns, but that requires us to spend a lot of time thinking about how to do that well. And so again, this is all my cautionary tale about the danger of complexity, that there's 70 plus different graphs available in Excel or other common statistical packages that allow you to visualize things in all sorts of different ways. And as we'll talk about later, you can do all sorts of mixing and animating and getting creative. You can make things interactive with dashboards, which we'll talk about. But just because something is possible doesn't mean it's a good idea. And just because you have a way of visualizing something, it doesn't mean that it's a good strategy for your user. And I think probably no better illustration of this comes through than the Challenger crisis in the 1980s. This is a space shuttle that blew up when I was a small child. I think I was like 4 or 5. It was a big national tragedy, in part because blowing up of a space shuttle and the loss of an astronaut crew was horrible in and of itself, but it was very closely watched because it was carrying a elementary school teacher along to do science as part of a big national competition that sort of drew attention to NASA and what it was doing. And the shuttle exploded because an O-ring, basically a little rubber seal, failed on one of the booster rockets. And the failure of O-rings is something that NASA had known about for a while. In fact, they had commissioned a study of O-rings and their failure and how that might be related to temperature. And it produced this kind of a graphic in which very reasonably an engineer was asked, go, collect data for us on rockets and O-ring failure and temperature. And so they began going through the first, batch of rockets, and then the second batch, 2 booster rockets on a shuttle, sort of incrementally or sequentially in order of launches, looking at the data for when the launch was in terms of the temperature that day, and then looking, is there an O-ring failure on one of those rockets and where did it occur? And that's a very reasonable sort of first pass of data collection. But as I'm looking at this graphic, and this isn't sort of the full range of the data, but as I'm looking at it, I don't really know what I'm looking for. I get intuitively that I'm looking at rockets because of the shape, and I kind of pick out A and B and 1 and 2, and I kind of get the sequencing. But I can't pick out a pattern very easily, and neither could NASA engineers. However, after the Challenger crisis, they went back and looked at that data again and organized it in a different way, this time in a scatter plot, and looking at, on the y-axis, sort of the level of failure that was observed for O-rings. And then on the x-axis, it's the temperature on the day of the launch. And this visualization is a little bit easier to see. It shows that most of the time you get temperatures for launches between 65 and 85 degrees. And most of the time you don't see a significant degrading of the O-ring sealing ability. I'm not an engineer. That seems like a reasonable way to describe what I think they're looking at with the O-ring damage index. But when temperatures start getting colder, and we've only got a handful of data points, we start seeing failures on those O-rings really with a high frequency. And then when we sort of take that sort of graphic and recognize that the estimated temperature on the day of the Challenger launch was supposed to be about 26 to 30 degrees, we realized that launching a shuttle in those cold temperatures was almost guaranteeing that there were going to be issues with the O-rings that potentially would lead to fuel spilling out and an explosion. I consider this to be a data visualization failure, that the data existed, the analysis had been done, but it had been done in such a way where it wasn't really possible to see the pattern, where if the data visualization had been presented in a way that communicated what was going on in that data, that communicated the story and the pattern clearly, a graphic like this one below, it's quite likely that NASA would have looked at that and said, we can't possibly launch a rocket under these conditions, and we need to scrub this launch.